Large-scale video localization is often restricted by duration adherence. Duration adherence is the technical requirement that a translated audio track matches the exact time signature of the original recording. AI reasoning models are now being used to manage these timing constraints during the translation process. Historically, forcing a translated script to fit a video's original timeline resulted in distorted, unnatural vocals. Creators were forced to choose between poor audio quality or the manual, labor-intensive rewriting of every segment. Automating the management of these physical timing limits allows for the localization of entire enterprise video libraries while maintaining both the original pacing and the intended meaning. Language translation is governed by a physical constraint. Different languages require varying amounts of time to express the same idea. This shows the data problem of syllable expansion. An 18-syllable English sentence translated into German undergoes a 40% increase, overextending the time window. Earlier AI solved this by artificially compressing the audio track, producing a chipmunk effect, too fast to process comfortably. A translation that is semantically accurate has little value if the resulting audio speed makes the content unwatchable. The current engineering approach prioritizes meaning and timing simultaneously. The system addresses pacing during the generation of the text rather than attempting to correct the audio after it is recorded. This flowchart illustrates semantic chunking, breaking a transcript into smaller, logical units based on natural pauses. Once the script is segmented, the reasoning model calculates the syllable count for each individual chunk. The system applies language-specific speaking rate assumptions to establish a strict time budget for each localized segment. The model modifies the translation to fit this budget before any audio is generated, ensuring the text matches the video's timeline. By making pacing a primary variable in the workflow, the algorithm ensures the translated text obeys the timeline constraints of the video. Listeners have a specific tolerance for altered speech. Generally, audio becomes unusable if it is slowed by more than 10% or accelerated by more than 20%. This chart shows segments in the 0.9 to 1.2x acceptable pacing window. Older models succeeded roughly half the time. The new pipeline reaches 83%. Tests achieved 85.5% semantic accuracy, and within 30 days, dubbed video exports increased 15%. The next development phase for automated localization involves multimodal integration. Multimodal integration is a system architecture that processes audio, video, and text data simultaneously to inform the translation. With pacing addressed at the text layer, research is now focused on replicating the original speaker's tone, emphasis, and nonverbal delivery for high-volume localization projects.